Today I'm going to tell you a story on carbon dioxide. It's about how can we think about turn carbon dioxide into liquid fuel using sunlight. In the past many decades, we are mainly using fossil fuel as our main energy source. And as a result, our planet Earth is facing many challenges and problems. For example, the CO2 concentration in the atmosphere is already passing 400 ppm. We have issue about global warming, we have the pollution issue, and the sea level is rising. So in order to mitigate these problems, we need to introduce more and more renewable energy technology into our overall energy portfolio. And one of such technology is this technology called artificial photosynthesis. And this technology is a process that can convert solar energy and store it into chemical bond. So every day when we're driving our car, we're basically burning the gasoline and using its energy and releasing the CO2 and the water back into the environment. And this artificial photosynthesis technology can turn the CO2 and the water back into chemical fuels using sunlight. So if we can come up with artificial photosynthetic system that can do this job with good efficiency and a low cost, then essentially we're offering a carbon neutral solution to our energy and environmental problem. Now the question is, how can we do this? Okay. So in this regard, we can certainly learn from nature. And if we look around, actually nature is doing this photosynthesis every day. We look at the green leaf. The green leaf basically breathes in CO2, absorbs the sunlight, and turns that into carbohydrates and release oxygen back into the environment. So nature is telling us this is durable. As a scientist, what we need to do is follow the chemistry and the physics over there and try to design an artificial photosynthetic system. Moving back more than 10 years ago when we launched this Helios program at the Lawrence Berkeley National Lab, we put this design, particular artificial photosynthetic design, on paper. In order to make this design work, we need to discover new class of semiconductor materials that capture sunlight. We need to discover a new class of catalysts to promote these chemical reactions we want to carry out. And over the past 10 years, we finally figured out ways to link a collection of biological and synthetic catalysts to the semiconductor nanostructures. And indeed, we can do the chemistry as we planned. So now we have this handheld device. If you bubble in CO2, shining with sunlight, we can basically produce chemicals, fuels, polymers, or even in some cases, pharmaceutical intermediates to make drugs. And even better, our artificial photosynthetic system, in terms of its solar to chemical energy conversion efficiency, is already better than nature. So with this artificial photosynthetic technology in hand, I think in the near future, our gas station would maybe what looks like this. So we will have this solar fuel generator installed on the rooftop of our gas station so that we can produce the gasoline on site. And not only that, this same technology can be used in deep space and Mars missions. And we can think about producing the chemical fuels in the deep space that satisfies the energy need in these deep space missions. Meantime, actually provide oxygen to the crew members. More importantly, the same concept can be applied to do the nitrogen fixation to make fertilizers in the deep space again. So I'm sure Matt Damon would love this idea because he can use the fertilizer to grow his potatoes on Mars. Thank you very much.